Assalamu alaikum. Today we will solve the numerical problems of chapter number 1, simple harmonic motion in waves. The first numerical is the time period of a simple pendulum is 2 seconds. What will be its length on earth? What will be its length on the moon? If gravitational acceleration on moon is equal to gravitational acceleration on earth divided by 6, where gravitational acceleration on earth is equal to 10 meter per second square. Here we will use the formula of time period of simple pendulum. T is equal to 2 pi under root L over G. The solution of first numerical 10.1. The given data in question, the time period is 2 seconds. Gravitational acceleration on earth is 10 meter per second square. The gravitational acceleration on moon divided by 6 will be equal to 1.63 meter per second square. We have to find length on earth and the length on moon, length of pendulum on earth and the length of pendulum on moon. We will use the formula time period is equal to 2 pi under root L over G. Here L is the length of pendulum and G is the gravitational acceleration. We have to take the square on both sides. By rearranging the values length, here we use the E for earth. L on earth is equal to time square into gravitational acceleration on earth divided by 4 pi square. We have to put the values over here. 2 second time period, 10 meter per second square gravitational acceleration, 4 is the constant and 3.14 is the value of pi. We solve these values and get the result 1.02 meter length on earth. We use the same formula for calculating the length on moon, but we have to change the value of gravitational acceleration on moon. T is equal to 2 pi under root L over G. Taking square on both sides. By rearranging the values, time period is 2 seconds and the gravitational acceleration on moon is 1.63 meter per second square divided by 4 into 3.14 square. We get the result 0.17 meter, that is the length of pendulum on moon. And the statement of second numerical is a pendulum of length 0.99 meter is taken to the moon by an astronaut. The period of the pendulum is 4.9 seconds. What is the value of G on the surface of the moon? The length of the pendulum is given and the time period of the pendulum is also given. So we have to calculate the value of G on the surface of moon. We have to use the formula of time period of simple pendulum. T is equal to 2 pi under root L over G. The solution of second question given in the question, length of pendulum 0.99 meter, time period is 4.9 seconds. So we have to find the value of G on the surface of moon. We have to use the formula T is equal to 2 pi under root L over G. First we have to take the square on both sides to cancel the square root. Taking square on both sides, T square is equal to 4 pi square L over G. We have to exchange the G with T square. Cross multiplication, G is equal to 4 pi square into length divided by time square. We have to put the values 4. 3.14 is the value of pi. We have to take the square. Length 0.99 meter divided by time period is 4.9 second square. By solving these values, we get the final result 1.63 meter per second square value of G on the surface of moon. Question number 3 is the find the time period of a simple pendulum of 1 meter length placed on earth and on moon. The value of G on the surface of moon is 1/6 of its value on earth, where gravitational acceleration on earth is 10 meter per second square. The length of the simple pendulum is given and the value of G on the surface of moon and on the surface of earth is given in the question. We have to find the time period of the simple pendulum. We use the same formula. Time period is equal to 2 pi under root L over G, the time period of a simple pendulum. Given length is given in the question. Length is 1 meter. Gravitational acceleration on earth is 10 meter per second square. Gravitational acceleration on the surface of moon is 1/6 of gravitational acceleration on earth. 10 divided by 6, we get the value 1.63 meter per second square. We have to find the time period on Earth and time period on Moon. Here the Earth E is used in the subscript for Earth and M is used for the Moon. We use the formula T is equal to 2 pi under root L over G. Here we use the letter E for Earth. Putting values 2 into 3.14 and length is 1 meter divided by gravitational acceleration on the surface of Earth is 10 meter per second square. By solving these values we get the result 2 seconds, that is the time period on the surface of Earth. We use the same formula for the Moon. Time period is equal to 2 pi under root length divided by gravitational acceleration. Here we use the M for Moon. Putting values 2 into 3.14, length is 1 meter. We have to put the value of gravitational acceleration on the surface of Moon 1.63 meter per second square. By solving these we get the final result 4.9 second time period on the surface of Moon. Fourth question, a simple pendulum complete one vibration in 2 seconds. Calculate its length when G is equal to 10 meter per second square. Time period is 2 seconds and the value of G is 10 meter per second square. We have to calculate its length on the surface of Earth. Here is the solution of fourth question. 10.4 time period is 2 seconds and the gravitational acceleration on the surface of Earth is 10 meter per second square. We have to find the length of the pendulum. We will use the formula T is equal to 2 pi under root L over G. We will take square on both sides. T square is equal to 4 pi square into L over G. By rearranging the values, length is equal to T square into G divided by 4 pi square. We have to put the values 2 seconds for time period and gravitational acceleration is 10 meter per second square divided by 4 into the value of pi is 3.14 square. By solving these values we get the final result 1.02, that is the length of the pendulum.